Many file types contain line-oriented formatted data. By line-oriented, I mean each line of the file contains some information, and that information is formatted in some particular way. Many file types are formatted but not line-oriented. So, for example, programming languages are not normally line-oriented. So, a statement in a programming language can span several lines, for example. In, files used for information exchange, such as JSON and XML, are not line-oriented either. So there are examples of tag-oriented languages where tags are used to delimit individual pieces of information. HTML is a tag-oriented programming language used to describe web pages. The file types that are formatted but not line-oriented are generally more difficult to read and are beyond the scope of this course. If you're interested in learning about parsing and parsing algorithms, you can follow the link here. And that takes you to a nice high-level overview of, or a nice high-level introduction to parsing algorithms. An example of a file that contains line-oriented formatted data is the etc. password file found on Linux systems. So etc. password is just a simple database containing basic information about authorized users. The format of the file is plain text. There's one record per line. Each record has 7 fields separated by colons. So the following is an example of a record in the etc. Is an example record that might be found in a password file. So you see that there are 7 fields: the username, then the password, then the user ID and the group ID. 5 is some general user information. So for example, here we've got the user's full name and their room location. There might be things here like their email address and other information. That user info field is called the GCOS field. The home directory, and then finally the login shell. In the password file, the fields are separated with a single colon. No field is allowed to use a colon as part of the field. So that means the home directory of a user is not allowed to contain a colon. Similarly, the user info field cannot contain a colon, which means it's not possible to put in a web page, for example, because you'd have to write HTTP : followed by the actual URL of their homepage. Line-oriented data can be read from a file using fgets. So just read each line of the file with the fgets function, and then you process each line, perhaps using the strtok function or scanf, scanf. The password.c is a little program that attempts to read an etc. password file using strtok. Okay, so let's take a look at that program. All right, so here we've got a program that tries to read in a file having the format of the password file. Here I'm gonna actually read in the etc. password file on my computer. So the first thing we do is open up the file for read access. If the file pointer is null, then obviously we couldn't open the file for some reason, so we exit. Otherwise, we read each line of the file. When we read a line of the file, we read it into a buffer of length 100. So here I'm assuming that the password file doesn't have lines that are longer than 99 characters long. Right? 99 plus 1 for the null terminator. To read in the file, we just use fgets and pass in the buffer where we want to read in the line into. Each time we read into the buffer, we parse that buffer using the function called Parse Record. And Parse Record returns a record struct containing information about the record, containing information about each record. And then finally, we print each record using the function print record. Print record simply prints each field of the password file. Let's look at the structure that's used to define a record. So our struct record simply has one field for each of the 7 fields in the password file. So we've got a pointer to a username. We've got a pointer to the password. We have the UID and GID. These are both unsigned integer values. The GCOS field, the HOMDIR, and the shell, these are all just pointers. Pointers to car. And so we're going to represent these using null terminated strings. The parse record function takes in a line of text, right? So a null terminated line where we assume that that line represents a record, or that line represents one line of the password file. And now we just read the files. We just parse the string one record at one field at a time. So the first field is the username. We're going to use strtok to tokenize the string. And this will hopefully split the string up into tokens where the colons separate the individual tokens. So remember, to use strtok, you call it the first time passing in the string you want to tokenize. Every other time, whenever you call the function again, we're going to pass in null, and that will let string tok continue from the point where it stopped in the previous call to strtok. So strtok returns null if it can't tokenize the string, so we check for that condition. If we ever fail to tokenize the string, then we just return the record the way it is at this point. If we successfully get a field from the string, we're going to, for the username, we're going to copy that string into the username field of the record. Now, let's go back up to the record. So the username field is just a pointer to a car. If we want to store a string in there, we need to allocate space to store the string. So to allocate space and copy the string, we're going to use this copy string function. So copy string takes in a pointer to a pointer, right? So a pointer to a pointer to car, right? So in other words, it takes in a pointer to a car pointer. And it takes in the string and the null terminated string to copy, right? Now we need to take in a pointer to a car pointer here because we want to actually change each one of these pointers that are inside the record, right? We need to assign each pointer to point to a newly allocated block of memory. So to change the value of the pointer from a function, we need to pass in a pointer to the pointer, right? So that's why destination here is a pointer to a car pointer. The length of the string to copy, we can get using str length, right? String length. Once we know the length of the string, we can allocate space to store the string, right? And we store the pointer returned from malloc in destination, right? But we dereference a destination to get the pointer to a car, right? So remember, dest is a pointer to car. If we dereference dest, we get a pointer to car, right? Which we can use to store the buffer or the array allocated by malloc. Once we've got the array, we can copy the source string into the destination buffer using string copy. Once we've read in the username, we can then read in the password. So reading in a string is always going to be the same sequence of steps. We're going to use strtok to tokenize the input string, right? Splitting the input string at colons. And then we're going to copy the string, the tokenized string, using the copy string function. So we process the password, for the user ID is an unsigned integer value. So instead of using copy string, we can just use A to I to convert the tokenized string to an integer value. The same is true for the group ID. Oh, wait a minute, there's a GID. There's actually a bug here, I just noticed. This is GID. And then we can do the same thing for the user information field. So for the user information field, we use copy string. For the home dir, again, we use copy string. And for the shell, the login shell, we use copy string as well. And then at the end of the function, we return the record R. Okay, so I've made that change to the password.c program, so I have to recompile it. So let's do that. And then let's run the program and see what we get. All right, so you can see that some of the fields look very strange. So for example, the shell, that doesn't look right. So that doesn't look like that doesn't look like any shell that I know of. You can also see that there seems to be a blank line being printed between home dir and shell in some cases. Right, so it looks like some of the field records have not been read correctly. However, up here you can see that the records are in fact read correctly. And it looks like the problem occurs when we get to message bus. So that's the first one where there's this blank line that's in between home dir and shell. So something's gone wrong here. If we look at the contents of the password file again and look for message bus, just right there, you can see that the first field, there's something for the password field, the user ID is here, the group ID is here, but the user information field or the GCOS field is not here. Now remember the way that strtok works, right? So it replaces the the delimiter with a /0. So that token gets replaced with /0. The next time you call the method, the strtok moves forward in the string looking for a non-token character. Right. So when I go to read in the user information field using strtok, it skips over this token, and now it finds that string there. Right. So when you look at what it prints out for the user information field under message bus, it actually prints out the home directory non-existent. Right. And so strtok can't deal with, or does not deal with, empty fields correctly. So here's an example of a record that has an empty user information field. Right. So when you tokenize the first 4 fields, right, it replaces every colon with a /0. Right. So there's the first field, second field, there's our /0, third field, fourth field, and we have a /0. Right. Now, the next time you call strtok, it skips over all of the delimiters. So it skips over that delimiter and it finds home.js.smith. So it's going to think that home.js.smith is the user information field. And it doesn't realize that there's a missing user information field. Right. And usually what ends up happening is you end up calling strtok too many times when this happens, because it skips over a field. So in this particular case, if we know that the GCOS field is missing, we can write some code that attempts to look for a missing user information field. So password2.c is a program that does exactly that. Right, so the same structure for the record, the same copy string function. We've now got another function called isGCOSEmpty. And we'll come back to this in a second. So let's look at Parse Record. So for the username, everything's the same. For the password, everything's the same. User ID, group ID, everything's the same. Right. So this is the line. This has got an error in it too. So after reading in the group ID, we're now going to try to read in the user information field, or the GCOS field here. And the first thing I want to do is I want to check, is that GCOS field empty? Now, the way we're going to do this is as follows. Right, so we've processed everything up to but not including the GCOS field. Right, so I know that the string that's currently stored in str is the string 1000 null terminator. Right, I know that the length of the string is 4. Right, so if I go and look at the 1, 2, 3, 4, the 5th character after the S, if that's a colon, then I know that the GCOS field is missing. Right, so again, the string length is 4, 1. So if I look at S plus 4, 1, 2, 3, 4, right, plus 1, so 5. That's the first character of the next string that GCOS is going to try to process. Right? If it's a colon, I know that the GCOS field is empty. So in our function is GCOS empty, we just get the length of the string S. Right? I've got a little assert statement in here. I'll explain that in a second. So what I'm going to do is I'm going to look at the character at index length plus 1 and check, is that equal to the colon? Right? If it is, I know that the GCOS field is empty. Otherwise, I know that the GCOS field is not empty. Right? The assert statement here should always be true, because I know that the string tokenizer function has overwritten the first colon with the null terminator. Right? So this assert statement is basically trying to communicate is basically trying to communicate the fact that that delimiter has been overwritten with the null terminator by strtok. The rest of the password2 program is the same. So if we run that program, I guess we should recompile it because I did make a change. Now you can see that all of the records, or all of the lines, have been processed. It looks correctly. They've all been processed correctly. If we go and look at the message bus, the message bus entry, we can see that it's now been properly processed. The GCOS field is empty, the home dir is correct, and the shell is correct. Right. You can actually generalize this technique. So you can actually check if any field is empty using the same trick, except for the first field, because the first field, for the first field, you'd have to check it if it's empty with a special case. So you know the first field is empty if the string S starts with the colon. Instead of using strtok, we can use the scanf function to tokenize the string. Scanf uses a format string similar to printf to control the tokenization of a string. It returns the number of tokens that have been successfully converted by the function. It returns 0 if the first token was not successfully converted. It returns a negative value if the string is empty, or if the string consists only of white space and the current conversion is not %c. Right? So in other words, if you try to use scanf to tokenize an empty string, it's going to fail. Right? It's going to return -1. So scanf uses implements different conversions for different types. Most of these conversions consume and discard all leading white space characters. And then the conversion ends when it sees a trailing white space character, or it finds the end of the string. The conversions %c and the square brackets can be used to convert white space. So we'll see an example of these in a second. The maximum field width can be specified after the percent sign. So if you specify the maximum field width, then that's equal to the maximum number of characters that the function is allowed to consume when doing the conversion. So remember that scanf is going to read in strings into an array. And you normally know what the length of the array is going to be if you're calling scanf, right? So in other words, because you're going to create the array to store the string in, you want to ensure that scanf does not overrun your array, right? So it doesn't try to write a string into your array that's longer than your array. So you can tell scanf how many characters to read by specifying the number of characters after the percent sign. If you use the %s conversion or the %bracket conversion, then you always get the null terminator in addition to the matched characters. So the array where you're storing the result in has to have storage for at least width plus 1 characters, where width is the maximum field width. The square brackets, you put a set of characters inside the square brackets. So %, opening square bracket, some characters, closing square bracket, matches any non-empty sequence of characters made up of the characters inside the square brackets. So for example, %square bracket ABC matches any non-empty string made up of only the letters A, B, and C. Right? So AAA, ABC, CBA, anything like that will match this conversion. If you use the caret as the first character, then this matches any non-empty sequence of characters not in that set of characters. So not ABC will match any non-empty string that does not include any of the letters ABC. Right? So XYZ will match, but XYZA will not, XAYZ will not match. In fact, that would just match the X. So it would stop matching when it sees when it sees an A, right? When it sees the first character in this set. Matching a string that contains spaces is problematic with scanf because %s stops converting at white space. So imagine you have a string that's got some spaces in it. If you just use a single %s to try to match that string, you only get the part of the string before the space. So to match a quoted string containing white space, you can use the following format string. Right? So on the next slide, I show you how to read this formatting string. So the \double quote, that matches the opening double quote. %square bracket, caret, \double quote, matches any sequence of characters that does not include the closing double quote. The \double quote matches the closing double quote. So let's look at some examples of using scanf, and then we'll look at an example of the password reading program that uses scanf instead of strtok. All right, so in the scanf demo program, I've got three string buffers of length 100. I've got 2 unsigned ints. And so these variables, these are going to hold the results that are converted using scanf. So we're going to start by trying to tokenize the empty string. And we're going to try to convert the empty string using the %s conversion, storing the results in the string str1. We're going to print the number of conversions that were successfully performed by %s. Right? So here we can, if scanf succeeds, we're going to get 1. right? So it can manage to convert one token successfully. If we get 0 or a negative value, that's going to indicate that scanf has failed. So let's just run the program with the first example and see what we get. Right, you see that we get n equals -1 for this value here. So a negative value indicates that scanf has encountered an error, which we expect because we know that you can't tokenize an empty string using scanf. Similarly, you can't tokenize a string containing only white space if you use %s, right? Because %s consumes all of the leading white space, right? So if you consume all of the white space in this string, you end up with an empty string, and you can't tokenize an empty string. So we're going to get the same result for the second example. Okay, if we want to tokenize a non-empty string, well, we can do that using %s. Right, so we're going to try to scan the string ABC. We're going to try to convert the characters in the string ABC using %s as the conversion. So we're going to try to read in a string. We're going to store the results into str1. Then we're going to print the number of conversions that were successfully completed, and then print out the value of str1. Right, so there we see that we got one successful conversion, and the string str1 is the string ABC. The next example shows you how to use the width specifier to only read in a limited number of characters. So on its own, %s will try to convert the characters in the string until it sees the end of the string or a space. So if you have a very long string with no spaces in it, then when it does the conversion, you might overflow the length of your buffer. So to prevent that from happening, you can pass in the maximum number of characters to read in from the string. So here I'm going to use 2. And we're going to store the result into str1. So here we should get the string AB, right? Because we're only going to read in 2 characters from the string. The C is left, remains on the input. So here we see that we get the string AB, which is what we expected, and there's one successful conversion. Okay, so on the next example, we've got a string. It's got a space in it, right, followed by more non-space characters. The conversion we're going to use is %2s. So we're going to read in 2 characters and store those into str1. Then we're going to try to convert the rest of the string using %s. So we're going to get AB in str1. Then we're going to try to convert the rest of the string using %s. Now, when %s reads the string, it stops at the space. So the second string is only the character C. And you can see that on the output here. Right? So 2 successful conversions. The first string is AB because we told it to read in only 2 characters. The second string is the string C because it stops after it sees the space. It stops when it sees the space after the C. In the next example, we've got a string followed by a space, followed by an integer, followed by a space, followed by a string. The conversion we use here is %s, followed by %u, followed by %s. Right? So string, unsigned int, string. We're going to store the results of the first conversion in the string str1. We're going to store the results of the unsigned int conversion in x1. We have to pass in the address of x1 though, because we need a pointer to an unsigned int value. Right? Because scanf needs to change the value of x1. The only way it can change the value of x1 is if we give it a pointer to x1. Right? And then finally, we store the rest of the string in the string string 2, sorry. So if this works, we should get 3 successful conversions, right? 1, then 2, and then 3. we do. Right, so we get the first string is ABC, the second string is XYZ, and then the value of X1 is 1. The next example uses the square brackets to read in a string. So here we've got the string CCBBAA and then BCAACB in all caps. So to convert the first part of the string, we're going to use % square bracket little case ABC. To convert the second part of the string, we're going to use % uppercase ABC. Okay, so remember, this will match any sequence of characters made up of only lowercase ABC. It will stop after it encounters a character that's not lowercase a, b, or c. So it'll stop when it sees the b. And then the next conversion is any string made up of the letters capital A, capital B, capital C. So we should get that string in str1, and we should get this string in str2. Right, and we do. Right, so 2 successful conversions with the expected strings stored in str1 and str2. And then finally, we've got an example of a double quote delimited string having spaces. Right, so here we've got a string with spaces, right? So it's double quoted. So notice the backslash double quote to escape the quote, right? Because we're inside of a pair of double quotes, so we have to escape the double quote if we want double quotes to be in the string. Our conversion, now you can have any conversion, you can put in any characters you want in the conversion string. So if I write colon, %u colon, then that will match a colon followed by an unsigned int followed by a colon. Right, so that matches that part of the string. The next conversion is the conversion that was shown to you a couple of slides ago that reads in a double quoted string. So that should read in all of this. Right. Now, when it does the conversion, though, every character that's matched does not. So when it matches a character that's not part of a conversion, it doesn't include that character in the conversion, right? So when I do colon %u, it doesn't try to write the colon into x1 because that doesn't make sense. Similarly, when I write backslash double quote, it's not going to include that double quote in the string str1. If I want the double quotes to be stored in the string str1, I have to add the double quotes myself later on. The rest of the conversion is colon followed by a string. So it's going to find the colon, and then it's going to store the string, no spaces, in str2. So if this works, we should get 3 successful conversions. And we do. And notice that str1 is, in fact, the string equal to string with spaces. Oh, the password3 program. The password3 program tries to read in the fields of the records using Scanf. And we're going to try to do it all in one line. So this is the advantage of using Scanf, is that if your file has if you know the format of the file, and you know that the file really is formatted the way you expect it to be, in other words, it's not missing any fields or there's no errors in the file, then you can normally read in the file with just a single, you normally read in a line of the file using just a single call to scanf. So here I'm going to allocate the strings for the username, password, user information, home dir, and shell fields using malloc directly. So I'm not going to use a function to allocate space for them. Right? Notice that you don't dereference that field in this case, like we did in the previous example. So assuming that, and I've allocated 64 characters for each buffer. So when I use scanf to read in the individual fields, I should specify the maximum width of each field. Right. For the username, I'm going to try to read in anything that's not a colon. Right. Then I'm going to try to match a colon. Then I'm going to try to match anything that's not a colon. Right. Then I'm going to try to match a colon. Right. Then I'm going to try to match an unsigned int followed by a colon, followed by an unsigned int, followed by a colon, followed by anything that's not a colon. Right. Again, colon, and so on and so on and so forth. Right. So let's see what happens when we run this program. And again, so now we get a similar result to what we got when we ran the original password program. It looks like some of the scanf has not successfully read in some of these, has not successfully read in the record. Right? And again, if we scroll back up to the message bus one, right, that's the first record where we see that a problem occurs. So again, we have this problem where an empty GCOS field is causing a problem. Right? Now the reason it causes a problem is because we match a colon, then we try to match something that's not a colon. Right? But if the GCOS field is missing, we have colon, colon. So this match fails. Right? And scanf stops at this point, or it doesn't read in the remaining fields. So again, using scanf the way we did fails when the field is empty. Now, scanf provides a conversion that returns the number of characters read so far. Right? So there's the conversion %n will store the number of characters that have been read by scanf when it reaches %n. Right? And so we can use this information to test if that GCOS field is empty. So let's look at password 4. So password 4, what we're going to do is we're going to try to read in the first 4 fields. Right? So we're going to try to read in the username, then the password, then the user ID, then the group ID. Right? And then we're going to use %n to get the number of characters that have been read after reading in the colon that follows the group ID field. Right? We're going to store the number of characters read in the variable cars read. Now, scanf also returns the number of conversions that were successful. So here we've got 1, 2, 3, 4 possible conversions. Right? So if n is less than 4, we know that there's a problem. Right? So we're going to return. So we simply return the incomplete record because we can't read in the rest of the record anyway. Now, at this point, we can check, is the GCOS field actually empty? Right? So the variable cars read is the number of characters read after converting the colon that follows the group ID field. Right? So that's the number of characters read. If we look at the character in the string s at that index, right, then that's 1 past the colon after the group ID flag field. Right? So if that character is also a colon, then I know that the GCOS field is empty. Right? And this actually works for any of the fields except the first. So you can use this trick to play. You can use this technique to check if any of the fields are empty. So if that field's empty, right, then I can simply store the empty string in the GCOS field. Right. I can advance s, right, past the second colon. Right. So that's what s equals s plus cars read plus 1 does. Right. So s plus s cars, s plus cars read is the pointer that points at the second colon after the group ID flag field. I add 1 to that, then that should be the first character of the, what's the next field? The first character of the homedir field. So at that point, then I can try to read in the homedir and the shell. If I don't find a colon sitting at the index cars red, then I know that there is something in the gcos field, so I should try to read in the gcos field. So I advance the pointer s to the position s plus cars red, right? So that's the pointer pointing at the first character of the gcos field, and now I just try to read in the gcos field homedir and shell in the usual way. So now when we run password 4, we should get the same results as password 2. Right? And so you can see that we can now successfully read in all of the records. Right? If we go and look at the message bus record, right, we can in fact confirm that the gcos field is empty. Right? The homedir and the shell have been read incorrectly. In this lecture, we looked at 2 different functions that can be used to tokenize a string. So strtok tokenizes a string by splitting the string at delimiter characters. Scanf can tokenize a string by using conversions to convert the various parts of the string. In both cases, you have to take some special steps to deal with fields that are empty. And how you deal with those depends on the function that you're using to tokenize the string.